I'm going to hand this over to Suki and Don, and we can continue to discuss this topic and other topics. So Suki and Don, please take it away.
Sure, I think we should first give the screen to Stella for our intro survey.
Yeah.
We will do the same as we did in the previous discussion roundtable. I will just post a link right now that you can just go there and submit your answer. It's anonymous. There is one question there that is asking you on which of the following barriers, which of the following you're considering barriers that are limiting you or any of your members of your team on while trying to pursue research questions at the synchrotron. So there are several options there. And there is also an option for other. If you don't feel any of the above really describes what you want to say, you can write under other, whatever you wish. We already have 10 responses so far. Okay, we have 40 responses. You can continue responding, but I will share my screen so we can see, get a glimpse of the results. So, can everybody see my screen? Okay. So it seems that most people think that there is not enough beam time available. I think that was discussed quite a lot. There are also some other big points like traveling, training, and a few other. So I will give this back to Don and Suki for discussion. You can continue replying.
Thank you, Stella. One of the quick things that I want to note related to this points back to a cartoon I showed during my talk earlier today, which is the classic image of survivor bias. The image that you saw that I didn't really talk a lot about on the slide is the picture of the airplane that came back from war with the holes in it. And the story goes that originally they look at the plane and they say the places where we see the holes are the places that we need to fix. But then they realized, of course, that the places where they don't see any holes are actually the places that they need to reinforce the most, because those are the places that if the plane is hit, then it doesn't come back at all. So I think we need to just recognize with that we have some bias in our data set here by the people who are answering the survey are the people who are here. And there are some barriers that will block people from participating in the workshop, perhaps, in addition to the barriers that the people here see a lot. So I think, we have a community here. The people on this call are generally, we're all people who have been very successful in research using synchrotrons. There's few people here who have not. And so it does make sense that not enough beam time is going to be a really common complaint for the people who are here. But some of the other complaints that we could have are going to be complaints that would be experienced by people who would not make it to this call and may not be able to be involved in our community. Let's see, I see, Stella, you're highlighting some of the ones that are the extras that people added, such as understaffing, software.
Yeah. We have some understaffing, software for data analysis, COVID, lack of knowledge regarding what is possible. Those are some of the extra things.
Yeah, I mean, I think information was another one that I was thinking we could have added to the poll. It's sort of related to training, but also sort of related to outreach. So does anyone else, Don, did you have anything that you wanted to add before we ask if anybody else wants to add to the discussion?
Well, I do find it interesting how significant lack of not enough beam time comes in compared to the others. And for the people that aren't here, they probably represent people that have less beam time and maybe haven't the experience and to see what a synchrotron can do for them. So I think that's maybe that's an issue that's always going to be there, that it's just going to be hard to have enough beam time. But I think the high pressure community, or the community represented by this workshop, is somewhat different than the total community that is, say, geoscience users of the synchrotron. Because a lot of use of the synchrotron is like a microprobe, or looking at, you take a sample after you've done the bulk of the work with it, you want to understand what it is. So it becomes one of the probes. You can do mass power, you can do SEM, TEM, microprobe, and you probably do all of those. And you also use synchrotron for the features that are significant from it, and obviously get very valuable information. On the other hand, I think for our community, it gets to the point of life or death, right? If you don't have access to the synchrotron, then the research project, you can't make your sample, or you can't, it becomes such an integral part of the study that your life ends up revolving around it. Student theses depend on having it. It's not one of the elements that can be dropped, but it's one of this. It's like the core, the essential part, and I think that makes this community sort of unique, and maybe something we need to be sure that the people that run the instruments and so forth are aware of its importance to us. Maybe the people that run the machines like to see a high rate of rejections, right? But this beamline's oversubscribed by a factor of 4 or something like that. Well, that begins to kill us. We can't afford that, because we need to do those experiments in front of the synchrotron, or else the fundamental research doesn't go on. And I think that's a difficult thing to know how to deal with from an organization point of view. And maybe one of the things that having a large compressor or a large, whatever this new organization will be called, can do is it can have more political influence to push these sort of themes forward. It just affects on, how, if a beamline isn't turning away 3/4 of the proposals, they're not successful. And that we can't let that remain as a criterion. Okay, I'm beating that horse too much, I think, but I do find this distinction sort of important and interesting as to how we can deal with it.
I see Vitali's hands raised. I also see we have a comment from our friendly NSF program officer reminding us that all things are limited in life.
Yes, everything except our power to change. Don, you're right. We have very limited resources, but from other side, what their community can help within limited budget is to help young scientists, newcomers to write proposal. So basically selection, nobody cancels. So we still have to have a best proposal toward the beam time. At the same time, promote new research who is not experienced. And that's what I can see community can help a lot within limited budget. Of course, if we can have more funds, we can build another beamline and say, okay, here is. But yeah, how to formulate right proposal and state the goal of the research help a lot. And of course, everyone welcome to contact Beamline staff. Usually we help in proposals and in the process of submitting and getting Beam time. Yeah.
Pamela,
Yes, can you hear me?
yes, we can.
Okay, good. I had put in software, and that's something that, you know, when we think about beam time is limited, at the same time, in my experience, whenever I come back from a beam time, no matter what it is, I have so much data, and I think we all do. Synchrotron data is incredibly rich. There's a lot of information and in the signals that we gather, and especially as we start, you know, combining even more probes, doing things simultaneously with our synchrotron experiments, we come back with all this data, and then we have to make some simplifying assumptions to kind of skim the cream off of it. And I feel like if we had better software, we could process data more quickly. We might even be able to come up with ways to extract a deeper level of data from the existing signals that we get. And so it's kind of this funny thing to say, we don't have enough. Yeah, we don't have enough beam time. And sometimes I feel like even at this point in my life, I have more data than a single human being could ever actually process to fully extract the richness of the information that's there. And I think that's something that, you know, as most of us are not trained as programmers, you know, having community resources devoted towards this sort of data extraction or information extraction from the data sets, I think would be really valuable.
Yes, Sean Ben.
Yeah, I agree with Pam. I think that's a very important issue for synchrotron data. You know, I can think of many examples. One of them is, for example, the monochromatic diffraction during deformation experiments. Many users look at the Q values, look at the HKL to calculate stress, but there's so much more information there. But for a particular user group, sometimes this information got buried. They publish a paper on stress, but the data probably contains a lot of valuable information on texture, and nobody later would look at those data. And so as a whole community, I think we need to think about how to address this issue, you know, make full use of all the data. You know, we're on the one hand, we're complaining we have not enough time. On the other hand, we throw away a lot of information that's already in the data. That's something that only a you know, a well-organized community can do that. I think individuals is very impossible to handle that issue.
I think one other follow-up I'd like to suggest is to think about making sure that we don't throw good time at bad samples. I think that another thing we haven't talked about is how, it's come up, I think, briefly before. And multiple people have talked about how construction of reproducible samples is really important. Sometimes just obtaining the composition and structure that you want is a major barrier to pursuing the research that you want to do as well.
Okay, I'll throw in another thing since nobody is speaking. We're doing high pressure experiments. I haven't heard many times, maybe once one person mentioned that. I think it was Nenad yesterday. The pressure scales. How do we reconcile the data using some community approved pressure scales, for example, between multi-envelope and the diamond envelope cell, so that we can be talking about the same pressures rather than one person uses one equation state, the other person uses another equation state on the same material, or at least report the volumes of the equation state standard so we can convert later on.
Yeah, and if more of the data are published in open databases so that it's easier to correct the existing data sets to match common pressure scales for common volumes, that can streamline things as well.
Yeah.
Any other thoughts about I think some of the themes that we had here were about considering the things that we need to develop in terms of our new capabilities as shared resources that are available at Beamlines or user labs. And also, we're bringing in one of our major themes related to how can we include a broader community in the new organization.
Vitaly.
Actually, following question, Suki, how we can engage more community in the synchrotron research. One of the important parts probably is to have at the synchrotron facility where you can come in, prepare your sample from starting from the beginning to the end and do experiment and get help to analyze data. That will be ideal. Unfortunately, it requires some resources, but with the help of a user community, you can still apply for the funds, and we keep building, for example, at JCCAR's different option for almost everything that you need to conduct experiment. So it's kind of like in your hands. If you really think that we have to go to this direction, it's one of the easiest way. So whatever you help us to build, add at facilities, it will be used everyone. And who knows, someone else will build for you as well, and you will use it. Same like we have a Raman system. It was built with collaboration with Carnegie, and everyone is benefiting that. It's a perfect system, works very well, and you don't need.
1 second, I'll be right there.
Yeah. Just like questions, so you can still keep discussing, and I will be glad to hear if anything else users want to see at the synchrotron facilities.
I think there's also always going to be some tension between people who want to see the technique development done in a central user facility versus done in individual labs.
That is fine. It's even better if you have in the lab and we can have at the synchrotron. So it's.
Can you help me with something?
Peter, your microphone is on too. Yeah, so if you build at the lab something that you really like, we will be happy to copy. It's vice versa. If you have something that we like, for example, laser cutting system, we started the JCCARs, now almost every lab want to use a laser cutting instead of EDM. So there are some process, and yeah, meetings like this can help to do that. Looks like young Faye.
Faye?
Yeah, so kind of in connecting to the discussions on like pressure calibration, technical development. So it would be nice for the community identify some of those, the people will benefit from that and be able to get, beam times and for that type of project. So oftenly, it happens is we are adding 3 shifts of the time. So you want to do, what you think is the most outcome, the most, high priority project for you. But if there is sometimes, people maybe will be interested to devote sometimes into more kind of benefiting the community. For example, assembly development. And certainly, I mean, I getting my fair shares and for my research, but if I do a development project, maybe requires a little bit more time, and so that should be into some kind of considerations and allocating beam times.
Yeah, what Faye, you just mentioned, things like the compressed assembly project. You know, one of the things that came up earlier was the comparison between our field and the low temperature geochemistry people. And I guess one of the questions that we can have is, where are we likely to find the economies of scale? Where, you know, I think we found a major efficiency for the community in that large volume press assemblies project. Because it made a big difference to people to have one place where they were mass manufacturing them. So there's that's one of the functions that Compress has served in the past to kickstart economy of scale for the high pressure community. Another one of the comments that I see Russ Kells left for us compared us to space-based remote sensing. I think it's also natural to note that some of the shapes of these challenges that we have are common with other fields. The issues that we're having in terms of data archiving and data mining, these things are not limited to us. The issues of time, beam time limitation is not so different from telescope limitation that the astronomers face. And they also are dealing with the same challenges in terms of trying to broaden their community while limited by a telescope time. Pam.
So Russ's point is very interesting, and it for me, it brings up the challenge of reaching across these basically interdisciplinary work, reaching across boundaries, because with the kind of training that I received as a young scientist and my students receive and the things I know how to do, it's really distant from the people who know about big data and data, you know, data science, and even, you know, programming effectively, right? It's like, okay, I can program, but I don't really know how to make a program that, you know, can run quickly and, you know, crawl through lots of data quickly. So we need to reach out to other people who have those skills, and they're in another discipline and they don't speak our language. And, you know, so that's a challenge that I think we're all aware of. And it's just, you know, interesting to maybe look for other fields where that kind of interdisciplinary wall has been broken down and people have figured out how to entrain data scientists into their community so that they can take advantage of their knowledge and skills.
I think part of what we have to do is have some of the staff be programmers that are working on. You know, I think our issues are unique enough. You get a data set, and the way it's encoded, the type of data it is, and so forth, is unique enough that it may be even difficult for one synchrotron facility or station to be doing a general enough program that can work for other stations as well. And you know, maybe that's not true. There's some continuity in that, but I fully feel the problem of being overrun with data. I've got stacks of data behind me that are just so deep that I'm really excited to get into, but with the tools I have there, it takes a long time. But you know, maybe that's what we need to do. Just decide to put resources to a programmer at the cost of you know, other support people that we have.
Which, you know, we can't make a relative decision about these different priorities without having some assessment of what do we have, how much data do we have, how badly do we need more beamline scientists and more synchrotron time.
Yeah,
You know, we have to cost benefit it. Hi, Ann.
Oh, hi. talk about software. From my knowledge of my user community, some of the user group, they have a certain capability of come up customized software. For example, I know a group has a very good software, at least can analyze data online, means because we do remote experiment, I collect data, then share with them real time. They can crank the data, in real time. Then we decide what to do next. However, because this group, they put in the effort, lots of effort actually, to develop this software. So I think they have the right of property. Intellectual property. So let's say if we want this group to share this software site with other group, how would we do it? Should we just ask them to share, or they will be co-author on the paper, or what? So I don't know, how this can be explored, because they've already have some software that's very good so far, based on my observation. I also know other users have some small software that's good for one thing or the other, but they are all just in the group or with the person. There's no license process to make them available to the whole community. So I don't know if there should be a mechanism for doing this in the future. Of course, if you have a professional program, that may be even better. Who knows? But these users, because they know exactly what they want and they are expert of this, let's say, rock deformation field. From this knowledge base, they are better than just a regular programmer. So that's just my comments.
In some ways, I think it's true that we could ask them for access to their programs. One of the things that happens is that you'll have many different platforms, whether it's MATLAB or IDL or lots of different software bases that the stuff's written in, and it may become too complicated to have as a general thing in the beamline. Vitaly.
In terms of software, 20 years ago was the same discussion. We need new software. We need the people. We need a person, programmer, to hire and write the program. It's failed. So we tried a few times, and it's never works very well, because as soon as you hire someone who is not interesting and who is not involved in the data analysis, it doesn't work. And for example, our diaptase that was developed, actually, Clemens Pressure, he is working here and he is using a lot. So when it starts working on every day, then you can get the result. And it's a beautiful piece of the software. So, but in terms of sharing the software, whatever is available, there are GitHub, and usually that's what we are doing, sharing between. So it's posted on GitHub and it's available, but we need to have some kind of systematic collection database. So we know where is it located and what the software is used for. I don't know, Yanbin maybe say, but for his experiment, he found that seismologists have nice software that he can adapt for his experiment. Right, Yanbin?
Yes, but working with other people, finding software to suit your experiments, that's one way. I've noticed a lot of the young junior scientists, maybe not a lot, but some of them are really into software. And we should actually encourage these people. I can think of, for example, Sebastian Merkel, when after his PhD, he spent a lot of time to develop this software to analyze the stress data and strain data. And now a lot of people are using it. We use that a lot. Clemens is another example, right? So he came in, run the experiment, and then he was so much into it, or maybe he was so much fed up with the lack of software, and he developed his own, and that, you know, it's really excellent software. Once we have this centralized organization, maybe I think one program is to try to find, to begin with, probably volunteers, to have a group of young scientists with interest in the software development to work on some specific problems. Of course, the whole community has to recognize their recommendation, their contribution. We need to acknowledge their contributions properly. For example, every paper you acknowledge the software, you use the paper that's already published. This will be a way to encourage people to devote their time and effort to this.
Ben Chen.
Yeah, okay. Yeah, hi everyone. So I would like to follow up with so what Suki made about the samples. So like well-characterized samples are very important for our high pressure experiment. So I hope that if some people it's also if a student want to have a hydrous mineral that has to be synthesized in a multi-envelope press. So I hope that we could provide the student some way to synthesize the sample in an offline lab. And another point I want to make is that so for the multi-envelope a cell sampling a facility led by Kurt Lennweber, so it's very successful. But for diamond cell work, we don't have a centralized facility because, for example, if a group want to do external heated diamond cell experiment, so it's very difficult to start from scratch to know how to put the thermocouple in the right place and then how to prepare the resistive heater. So compress support. So in the past few years, supported our group's effort in developing the external heated diamond cell technique, and then so we now offer those kind of heaters, and we also develop enclosure for pushing the external heating to much higher temperature under vacuum, and it also has a membrane control. So those will be also freely available to the community. So my question would be in the future organization. So I'm wondering if there will be a deck facility what the Kurt is doing for the multi-envelope press for the multi-envelope cell sampling facility.
I would say that that probably needs a bottom-up sort of proposal for that. I think I would imagine that would get a lot of support in compressed, given the success of Kurt's operation with the multi-envelope. I mean, it's a perfect analog, but it probably needs the proposal to rise rather than. I don't think it will come down from above. That would be my bet. Kurt.
Yeah, thank you, Ben, for the shout out, as they say. I think that a diamond cell project, I would use it. I really want to do externally heated DAC, but I've tried a couple of times to get it going, and I never have enough time to actually get it going. So if someone like Ben does a project, it would be great. But Don is right. It has to be submitted as some kind of internal proposal, right? That's how the one I have started at Santa Cruz a long time ago. And it wasn't actually called for by the group. but on the airplane on the way back to ASU, I thought we should do that. It was actually only one person. That was David
Walker.
Walker. Dave Walker was the one who said we need a machine shop. He said we need a machine shop for multi-anvil part.
What Ross suggested, probably it might solve the problem with the funding. So do you want to comment?
I wasn't sure whether the comments in the chat were tongue in cheek.
Yeah, but what Binchen say about their our centralized facility for the sample synthesis, sample preparation, we really need it. And actually, when HP Sync was created, we was discussing to have facilities and even start to build the lab here at 401 building. We still have a lot of equipment there to from the sample preparation, sample manipulation, cutting, FIB. All this stuff should be in one place with an expert operating it and helping others. That's possible. And yeah, I'm not sure how we can get it in, but definitely it should be on the table for consideration.
It seems to be part of a natural life cycle. As the community matures, we centralize the facilities with expertise, and the students don't learn how to do it anymore.
And do you know what will be next? We will create high pressure institute, and we will have a PhD student, we have graduate students, and then it will be a centralized facility, train the people, and then spread out our country. That kind of like ideal situation, how you can train people.
Well, we have reached a couple minutes past 7 o'clock or 6 o'clock in your central time. So if anyone has any final thoughts, now would be a good time. Otherwise, we could adjourn for the day.
We should have a beer hour after this.
Karaoke. Where's karaoke when we need it?
Karaoke man. Where's the karaoke man? Matt. Well, he's probably already drinking his whiskey.
Well, first of all, don't pigeonhole me. All right. I have no drinking.
Sorry.
I think he's there.
Yeah, I am here. I'm here.
Yeah.
I think last time he drank a rum at the conference meeting.
Yes. Yes, that's where I started.
Well, then, thanks everyone for a great day, and we will see you again in the morning.
Thanks. Bye.
Thanks, everyone.
Bye.
Bye-bye.
Bye.